Magnesium is one of the most biologically important S-block elements because it is essential for both plant and animal life. Although metallic magnesium is highly reactive, it does not exist in its free metallic form inside living organisms. Instead, it is present as the magnesium ion, Mg, which participates in hundreds of vital biological processes. Magnesium is required for photosynthesis in plants, activates hundreds of enzymes, supports energy production through AP, strengthens bones and teeth, regulates muscle contraction, and contributes to normal nerve function. The infographic highlights these major biological roles and explains why magnesium is indispensable for life on Earth. One of the most remarkable functions of magnesium is its role in chlorophyll, the green pigment responsible for photosynthesis in plants. Magnesium occupies the central position in every chlorophyll molecule, where it is surrounded by a ring of nitrogen-containing atoms. This central magnesium ion enables chlorophyll to absorb energy from sunlight efficiently. During photosynthesis, plants use light energy to convert carbon dioxide and water into glucose, which serves as food for the plant, while oxygen is released as a byproduct. Without magnesium, chlorophyll molecules could not function properly. Photosynthesis would stop, plants would be unable to produce food, and the oxygen supply essential for most life on Earth would be severely affected. This makes magnesium one of the most important elements for sustaining ecosystems and maintaining life on our planet. Another extremely important role of magnesium is enzyme activation. Enzymes are specialized proteins that act as biological catalysts, speeding up chemical reactions inside living cells. More than 300 enzymes in the human body require magnesium ions to function properly. Magnesium helps stabilize enzyme structures and assists them in binding with their substrates, allowing countless biochemical reactions to occur efficiently. These reactions include energy metabolism, DNA synthesis, RNA synthesis, protein formation, cell growth, and cellular repair. Without sufficient magnesium, many essential metabolic reactions would slow down significantly, affecting the normal functioning of cells and organs. Magnesium also plays a central role in energy production because it is closely associated with adenosine triphosphate, or API, which is known as the energy currency of the cell. Nearly all API inside cells exists in the form of a magnesium-API complex. Magnesium stabilizes AP molecules and allows enzymes to release stored energy whenever cells require it. Every activity that requires energy, including muscle contraction, nerve impulse transmission, protein synthesis, active transport, and cellular metabolism, depends on magnesium. Without adequate magnesium, the body's ability to produce and utilize energy would be greatly reduced, leading to weakness, fatigue, and impaired cellular function. The infographic further illustrates magnesium's importance in maintaining healthy muscles and bones. Approximately 60% of the body's magnesium is stored in bones, where it contributes to bone structure and strength alongside calcium and phosphorus. Magnesium also helps regulate calcium metabolism and supports the proper formation of bone tissue. In muscles, magnesium works together with calcium to control contraction and relaxation. Calcium stimulates muscle contraction, whereas magnesium promotes muscle relaxation after contraction. This balanced interaction ensures smooth and coordinated muscle movement. When magnesium levels become low, muscles may remain partially contracted, resulting in cramps, spasms, twitching, stiffness, or weakness. Magnesium is equally important for the nervous system. Nerve cells rely on magnesium to regulate the movement of ions across cell membranes and maintain normal electrical activity. Magnesium helps stabilize nerve cell membranes, supports neurotransmitter release, and prevents excessive nerve stimulation. Adequate magnesium contributes to normal brain function, healthy nerve communication, and proper coordination between the nervous and muscular systems. A deficiency may lead to increased nervous excitability, tremors, irritability, and abnormal muscle contractions. Another essential function of magnesium is supporting cardiovascular health. Magnesium helps regulate the electrical activity of the heart muscle, ensuring a normal heartbeat. It also assists in relaxing blood vessels, improving blood circulation, and maintaining healthy blood pressure. Magnesium works closely with potassium and calcium to coordinate the contraction and relaxation of cardiac muscle cells. An adequate magnesium intake therefore contributes to maintaining normal heart rhythm and overall cardiovascular function. The infographic also emphasizes that magnesium is obtained through a balanced diet. Excellent dietary sources of magnesium include spinach, almonds, pumpkin seeds, peanuts, whole grains, beans, dark chocolate, avocados, bananas, green leafy vegetables, legumes, nuts, seeds, and various plant-based foods. Magnesium is absorbed through the digestive system and distributed throughout the body, where it supports numerous physiological processes. Since magnesium cannot be synthesized by the body, regular dietary intake is essential for maintaining normal health. Magnesium deficiency, known as hypomagnesemia, can result from poor nutrition, digestive disorders, chronic alcoholism, prolonged diarrhea, certain medications, or kidney diseases. Symptoms may include muscle cramps, fatigue, weakness, tremors, irregular heartbeat, numbness, anxiety, sleep disturbances, and impaired nerve function. Severe deficiency can interfere with normal heart rhythm and muscle function. Conversely, excessive magnesium intake from food is rare because healthy kidneys efficiently remove excess magnesium from the body. However, extremely high magnesium levels resulting from excessive supplementation or kidney failure may cause low blood pressure, muscle weakness, slowed heartbeat, and impaired nervous system function. The biological significance of magnesium extends beyond humans to the entire plant kingdom. Since magnesium is the central atom of chlorophyll, every green plant depends on it for photosynthesis and growth. Healthy plant development ultimately supports all food chains, making magnesium essential not only for individual organisms but also for the survival of ecosystems worldwide. Magnesium also interacts closely with other important minerals, particularly calcium and potassium. Together, these electrolytes regulate muscle contraction, nerve transmission, enzyme activity, and cellular metabolism. Maintaining an appropriate balance among these minerals is essential for proper physiological function. A deficiency or imbalance in any one of them can disrupt multiple body systems. Magnesium exists in living organisms as the magnesium ion, Mg, and performs numerous essential biological functions. It serves as the central atom of chlorophyll, making photosynthesis possible in plants. It activates hundreds of enzymes involved in metabolism, supports AMP-dependent energy production, strengthens bones and teeth, regulates muscle contraction and relaxation, maintains healthy nerve function, supports cardiovascular health, and contributes to normal cellular activities throughout the body. Because of its indispensable role in both plants and animals, magnesium is considered one of the most biologically important S-block elements and is essential for sustaining life on Earth. Calcium is one of the most abundant and biologically important S-block elements in the human body. Although metallic calcium is highly reactive and never exists in its free metallic form inside living organisms, it is present as the calcium ion, K, which performs numerous essential physiological functions. Nearly 99% of the body's calcium is stored in bones and teeth, where it provides strength and structural support, while the remaining 1% circulates in the blood and body fluids, playing vital roles in blood clotting, muscle contraction, nerve impulse transmission, hormone secretion, and many other cellular processes. Even though this circulating calcium represents only a small fraction of the total body calcium, it is absolutely essential for life. The infographic highlights the major biological functions of calcium and explains why it is indispensable for the normal functioning of the human body. The most well-known function of calcium is bone formation and maintenance. Bones are living tissues that are continuously broken down and rebuilt throughout life in a process known as bone remodeling. Calcium combines with phosphate to form calcium phosphate crystals, primarily hydroxyapatite, which give bones their hardness and strength. During childhood and adolescence, calcium supports rapid bone growth and skeletal development, while in adults it helps maintain bone density and repair damaged bone tissue. If dietary calcium intake is insufficient, the body begins removing calcium from bones to maintain normal blood calcium levels, gradually weakening the skeleton and increasing the risk of osteoporosis and bone fractures. Calcium is equally important for maintaining healthy teeth. Tooth enamel and dentin contain large amounts of calcium in the form of hydroxyapatite crystals, making teeth hard and resistant to wear. Adequate calcium intake during childhood supports the proper development of permanent teeth, while sufficient calcium throughout life helps maintain strong teeth and reduces the risk of tooth decay and structural weakness. Calcium works together with phosphorus and vitamin D to ensure normal tooth mineralization and long-term dental health. Another essential function of calcium is its role in blood clotting. Whenever a blood vessel is injured, the body activates a complex series of chemical reactions called the coagulation cascade to stop bleeding. Calcium ions participate in several important steps of this process by activating clotting proteins and enabling them to interact with one another. Without adequate calcium, blood clot formation would be delayed, increasing the risk of excessive bleeding. For this reason, calcium is recognized as one of the essential factors required for normal blood coagulation and wound healing. Calcium also plays a central role in muscle contraction. Every movement of the body, whether voluntary or involuntary, depends on calcium ions. When a nerve impulse reaches a muscle cell, calcium ions are released from specialized storage compartments inside the muscle fibers. These calcium ions bind to regulatory proteins, allowing the muscle proteins actin and myosin to interact and produce contraction. After the contraction is complete, calcium is pumped back into storage, allowing the muscle to relax. This continuous movement of calcium enables all skeletal muscles, smooth muscles, and even the heart muscle to contract and relax in a coordinated manner. Without calcium, muscles would be unable to contract properly, resulting in weakness, spasms, or paralysis. The infographic also illustrates calcium's vital role in nerve signaling. The nervous system communicates through electrical impulses that travel along nerve cells. When an electrical signal reaches the end of a neuron, calcium ions enter the nerve terminal through specialized calcium channels. This influx of calcium triggers the release of neurotransmitters, the chemical messengers that carry signals from one nerve cell to another or from nerves to muscles. Without calcium, neurotransmitter release would not occur efficiently, and communication throughout the nervous system would be severely impaired. Consequently, calcium is essential for normal brain function, sensation, movement, memory, and coordination. Calcium is also involved in numerous cellular processes beyond those highlighted in the infographic. It acts as an important intracellular signaling molecule that regulates hormone secretion, enzyme activation, cell division, gene expression, immune responses, and many metabolic pathways. Because calcium functions as a universal cellular messenger, even slight changes in blood calcium concentration are carefully regulated by the body. The concentration of calcium in the blood is maintained within a very narrow range through the coordinated actions of three important hormones. Parathyroid hormone increases blood calcium levels by stimulating calcium release from bones, increasing calcium absorption from the kidneys, and activating vitamin D. Vitamin D enhances calcium absorption from the intestines, allowing dietary calcium to enter the bloodstream more efficiently. Calcitonin, produced by the thyroid gland, helps reduce blood calcium levels by promoting calcium deposition into bones. Together, these hormones ensure that calcium concentrations remain stable despite changes in dietary intake. The infographic also highlights several rich dietary sources of calcium. Excellent sources include milk, cheese, yogurt, leafy green vegetables such as spinach and kale, broccoli, almonds, sesame seeds, tofu, sardines with edible bones, and various fortified foods. A balanced diet containing these foods usually provides sufficient calcium for maintaining healthy bones, muscles, nerves, and other physiological functions. Vitamin D is equally important because it greatly improves the absorption of calcium from the digestive tract. Calcium deficiency, known as hypocalcemia, may result from inadequate dietary intake. Vitamin D deficiency, kidney disorders, or hormonal imbalances. Symptoms can include muscle cramps, tingling sensations, numbness, muscle spasms, weak bones, brittle nails, abnormal heart rhythms, and increased risk of fractures. Long-term calcium deficiency during childhood may impair bone growth, while in adults it can contribute to osteoporosis, a condition characterized by reduced bone density and increased fracture risk. Conversely, excessive calcium intake, known as hypercalcemia, may occur due to certain medical conditions or excessive supplementation and can lead to kidney stones, constipation, muscle weakness, confusion, and impaired kidney function. Therefore, maintaining an appropriate calcium balance is essential for overall health. Calcium works closely with several other minerals, particularly magnesium and phosphorus. Magnesium helps regulate calcium movement into and out of cells, while phosphorus combines with calcium to form the mineral crystals that strengthen bones and teeth. Together, these minerals support skeletal integrity, muscle function, nerve transmission, and numerous metabolic activities throughout the body. Calcium exists in living organisms as the calcium ion, Ca, and serves as one of the most essential minerals required for life. It builds and maintains strong bones and teeth, supports normal blood clotting, enables muscle contraction, facilitates nerve impulse transmission, regulates numerous cellular signaling pathways, and contributes to the healthy functioning of virtually every organ system. Nearly 99% of the body's calcium is stored in bones and teeth, while the remaining 1% performs countless physiological functions that are critical for survival. Because of these diverse and indispensable roles, calcium is regarded as one of the most biologically important S-block elements in both human physiology and overall health. Lithium is one of the most important S-block elements in modern technology and is often called the metal of the future. It is the lightest metal in the periodic table and possesses a unique combination of low density, high energy storage capacity, excellent electrical performance, and a very high strength-to-weight ratio. These exceptional properties make lithium indispensable in numerous industries, including rechargeable batteries, electric vehicles, consumer electronics, renewable energy storage, aerospace engineering, advanced materials, and space technology. The infographic illustrates how lithium has become a key material driving technological advancement and the global transition toward clean and sustainable energy. One of the most significant industrial applications of lithium is in rechargeable lithium-ion batteries. Today, lithium-ion batteries power billions of electronic devices around the world, including smartphones, laptops, tablets, smartwatches, wireless earphones, cameras, drones, and power tools. Lithium is ideal for rechargeable batteries because it is the lightest metal and has a very high electrochemical potential, allowing batteries to store a large amount of energy while remaining compact and lightweight. Lithium-ion batteries also have a long lifespan, high charging efficiency, low self-discharge, and can be recharged thousands of times without significant loss of performance. These advantages have made lithium-ion batteries the dominant energy storage technology for portable electronics. Lithium also plays a crucial role in electric vehicles, commonly known as EVs. Almost every modern electric car uses lithium-ion battery technology because lithium provides the high energy density required for long driving ranges while keeping the battery relatively lightweight. A lighter battery reduces the overall weight of the vehicle, improving acceleration, efficiency, and energy consumption. Faster charging capabilities and longer battery life further enhance the practicality of electric vehicles. As governments worldwide promote clean transportation to reduce carbon emissions, the demand for lithium continues to increase rapidly, making it one of the most strategically important industrial metals of the 21st century. Another major application of lithium is renewable energy storage. Renewable energy sources such as solar panels and wind turbines generate electricity only when sunlight or wind is available. Lithium-ion battery systems store this excess electricity and release it whenever energy demand exceeds supply. Large lithium-based battery storage facilities are now being used to stabilize electrical grids, improve energy reliability, reduce dependence on fossil fuels, and support the integration of renewable energy into national power systems. This capability makes lithium an essential component of the global shift towards sustainable energy production. Lithium is also widely used in aerospace and space exploration. Because lithium has an extremely low density, it is used to manufacture lightweight, high-strength alloys for aircraft, satellites, rockets, and spacecraft. Lithium-containing aluminum and magnesium alloys reduce the overall weight of aerospace structures without compromising their mechanical strength. A lighter aircraft requires less fuel, increases payload capacity, improves efficiency, and lowers operating costs. In space missions, where every kilogram significantly affects launch costs, lightweight lithium alloys provide enormous economic and engineering advantages. The infographic further highlights lithium's role in advanced engineering materials. Lithium is added to specialized alloys to improve their strength, durability, and corrosion resistance while maintaining low weight. These materials are used in high-performance automobiles, racing cars, bicycles, military equipment, precision instruments, and numerous industrial components. The excellent strength-to-weight ratio of lithium-containing alloys enables engineers to design lighter, stronger, and more energy-efficient products. Lithium is also used extensively in the electronics industry beyond batteries. It contributes to the manufacture of rechargeable power systems for smartphones, tablets, laptops, wearable devices, portable medical equipment, wireless communication devices, and numerous smart technologies. As electronic devices become smaller, more powerful, and more energy efficient, lithium continues to play an increasingly important role in meeting these technological demands. In addition to batteries and alloys, lithium compounds are used in the production of heat-resistant glass and ceramics. Lithium carbonate and lithium oxide improve the strength, durability, and thermal shock resistance of specialty glass and ceramic materials. These products are used in laboratory glassware, induction cooktops, ovenware, smartphone screens, telescope mirrors, and high-temperature industrial equipment. Lithium-containing ceramics also exhibit excellent dimensional stability under extreme temperatures, making them valuable in scientific and engineering applications. Lithium compounds are further employed as lubricating greases in heavy machinery and industrial equipment. Lithium-based greases possess excellent resistance to heat, moisture, oxidation, and mechanical stress. These lubricants are widely used in automobiles, aircraft, electric motors, construction machinery, manufacturing equipment, and industrial bearings where reliable performance under extreme operating conditions is essential. Another important industrial application is nuclear technology. Certain lithium isotopes, particularly lithium-6, are used in nuclear reactors and in the production of tritium, an isotope of hydrogen used in nuclear fusion research. Lithium compounds also serve as coolants and neutron absorbers in specialized nuclear systems, contributing to advanced energy technologies and scientific research. The infographic also illustrates the industrial journey of lithium, beginning with lithium mining. Lithium is extracted primarily from mineral ores such as spodumene and from underground salt-rich brines. After extraction, the lithium undergoes chemical processing to produce high-purity lithium compounds, which are then used in battery manufacturing, alloy production, ceramics, lubricants, and other industrial applications. These materials are subsequently incorporated into electric vehicles, consumer electronics, renewable energy storage systems, aerospace components, and numerous advanced technologies that support modern society. Several unique properties explain why lithium has become so valuable in industry. It is the lightest metallic element, allowing manufacturers to produce lightweight products without sacrificing performance. Its exceptionally high energy density enables compact batteries to store large amounts of electrical energy. Lithium exhibits excellent electrochemical behavior, making it highly efficient in rechargeable battery systems. It also forms strong yet lightweight alloys with aluminum and magnesium, providing outstanding mechanical performance while reducing overall weight. In many applications, lithium-containing alloys also demonstrate improved corrosion resistance and enhanced durability. The rapid growth of electric vehicles, renewable energy, portable electronics, and aerospace technology has transformed lithium into one of the world's most economically important strategic resources. As nations continue investing in clean energy, energy storage, and advanced transportation systems, global demand for lithium is expected to increase significantly in the coming decades. Consequently, lithium has become a key material supporting sustainable technological development and the transition toward a low-carbon future. Lithium is the lightest metal and one of the most valuable industrial elements due to its unique combination of low density, high energy storage capacity, excellent electrical performance, and exceptional strength-to-weight ratio. It is widely used in rechargeable lithium-ion batteries, electric vehicles, renewable energy storage systems, aerospace alloys, advanced engineering materials, heat-resistant glass and ceramics, industrial lubricants, nuclear technology, and numerous consumer electronic devices. These remarkable properties have made lithium an indispensable material in modern industry, driving innovation, supporting clean energy technologies, and playing a central role in building a more sustainable future.